For lesson 3, we are going to look at proportional relationships. So what does it mean for ratios to be proportional versus non-proportional? And we're going to look at it through 3 different lenses. First, looking at a table. So in a table, the ratio of y to x should all simplify to the same value if it is proportional. So, for example, in a table like this, x is first, y is second. So if I look at this ratio here, our y value is 6 over an x value of 2. In our next ratio, our y value is 12 over an x value of 4. And in our last ratio here, our y value is 18 over an x value of 6. If I simplified all of those, 6 divided by 2 is 3, so 3 over 1. 12 divided by 4 is 3. 18 divided by 6 is 3. And all of those simplify to the same value. So they all have a constant slope or a constant rate of change. It is not proportional if that is not true. So that ratio of y over x does not simplify to the same value. So if I look at here, when we have the horizontal table, x is first, y is second. It's just x is on top, y is on the bottom. Our ratio, we flip it around. Y is 1 over an x value of 0. Y is 3 over an x value of 1. Y is 5 over an x value of 2. Y is 7 over an x value of 3. So these are already simplified and they do not equal each other. So therefore it is not proportional. Okay, next we looked at tables. Now we're going to look at graphs. So graphs must make a straight line. So that's the first thing that must be true. And they must pass through the origin. So the point 0, 0. So to be proportional, both of these have to be true. It's not one or the other, it is both. So in this example, it passes through the origin and it also is a straight line. So that is proportional. Graphs that do not pass through the origin are not going to be proportional, and they may not make a straight line. So it could be straight and not pass through the origin, and then it's not proportional. So even though this one's straight, it doesn't go through the origin. You could also have something like this that goes through the origin, but is not straight. That is not going to be proportional. So just because it's straight doesn't mean it's proportional. It has to go through the origin. Just because it goes through the origin doesn't mean it's proportional. It has to be straight. This one is not. So both of those examples are not. And then the last type we're going to look at is an equation. So equations that are proportional must be in the form y equals k, well, yeah, we're going to say y equals kx for it to be proportional. And we'll talk about the other form in a minute. So I'm not going to look at this part right here. So if it is proportional, it's y equals kx. There is nothing added or subtracted. So there's nothing added into this. You would have a numerical value where x is, or where k is, sorry. So like y equals 1/2 x, or y equals negative 5x, or y equals 3.4x. So anything where there's nothing being added to that term, just something being multiplied by x, that is proportional. The opposite is, if we have the form y equals mx plus b, people get confused because they're like, why does this have k, why does this have m? They are essentially saying the same thing. The difference is that k here is representing a constant. You're saying, hey, it's k because it's constant, it is proportional, versus here it might not be. So in y equals mx plus b, something is added or subtracted to the m x. So in this example, we don't just have y equals 3x, we have this plus 4. That is what makes it not proportional. Or if I had y equals negative 1/2 x plus 3, not proportional because it has something added. Or if I had y equals negative 1.5 x minus 7, not proportional because something's being subtracted. So let's practice identifying that from problems here. So first one, determine if each graph, table, or equation is proportional or not, then explain. So your explanation is either in word form or by using math, okay? So if I look at this, we have a graph. It goes through the origin. It is straight, so yes. So my reasoning, it goes through the origin and is straight. So that's my reasoning. Both of those are true. Number 2, looking at the equation. I'm looking to see, is anything being added or subtracted to that x value? No, therefore it is proportional. And all I'm going to say for my reasoning, nothing is added or subtracted. Or maybe you say it's in the form y equals kx. It's in that constant form. Number 3, looking at the equation again. This time I see that something is being subtracted from that kx value, that mx value. So no, it is not proportional. And I would say something is subtracted from mx. Or you can say it's in the form y equals mx plus b. Okay, number 4, looking at a table. Remember, we're doing the ratio of y over x. So we're starting with our y's first. We've got 6 over 0, 9 over 3, 12 over 6, 15 over 9. And as long as I have a few here, that should be enough to check. The 0 one's a little bit confusing. Let's look at the others. 9 over 3 simplifies to 3 over 1. 12 over 6 simplifies to 2 over 1. 15 over 9 simplifies to 5 over 3. And none of these are equal. So your work right here could just be this work showing that they aren't equal. The other indicator should be that if it's constant, it's going through the point 0, 0, not 0, 6. Number 5, is this proportional? So we've got x and y. So I'm going to look at the y over x. So we've got 1/2 over 8. Is that the same thing as 1 over 16? Is that the same thing as 1.5 over 24 and so on? Well, if we do 1/2 divided by 8, we get 1/16. If I do the math here, 1.5 divided by 24, I get 1/16. So for each of these, they all simplify to the same value. So my reasoning, they simplify to the same value. And last one, is it proportional? Well, it goes through the origin, that's part 1, but it is not straight, it is curved, so no. And I would say it is not a straight line. And that's it.